全球华语摩课师的同学们，大家好，我是台湾科技大学阮胜章教授，欢迎大家来参与这门物联网系统平台与应用的课程。在上节课中，我们介绍了树莓派的历史以及树莓派各组件的介绍。接下来，我们将介绍一些树莓派的应用实例。由于树莓派价格低廉，还同时兼具微型电脑的完整功能，非常适合各种科学或日常生活的应用，因此上市以来广受各界的喜爱。无论是学生、教授或者是工程师，都相继采用树莓派作为软硬体的核心，设计与开发相当有趣的应用。我们以下列举几个有趣的树莓派应用实例。使用树莓派并接上喇叭或音响，也可以用来播放音乐档案。使用个人电脑时，音乐也不至于中断。树莓派也可以设计成智慧型手机的音乐串流播放器，利用蓝牙或者是 WiFi 传输与手机做连接，在智慧型手机中选取音乐与即时播放。
If you had a chance to see my Ultimate Audio Player video, you probably couldn't help but notice the low-budget ghetto vibe it had. The wires nest and the half enclosure looked very DIY and not so much hi-fi. Running Volumio, it did serve me well for the past 6 months, but it was high time for an upgrade. Meet the Ultimate Audio Player 2.0. While the first incarnation was based on the Type A RPI with the Audiophonics DAC, the new one rocks a brand spanking new Raspberry Pi 3 and the HiFi Berry DAC Plus Pro in a stylish matte black steel case. RPI 3 with its quad-core CPU and the gig of RAM is probably a little bit of an overkill for a music player, but who cares? The DAC Plus Pro is also a step up from the Audiophonics DAC. It's HiFi Berry's top-of-the-line DAC. It features a Burr Brown chip, an integrated clock generator, and mandatory gold-plated RCA connectors. While it doesn't need any soldering whatsoever, as it slides right onto the Pi's GPIO pins, assembling it in the steel case is a little bit tricky. First, you put the Pi on the bottom half and secure it with the 2 shorter brass standoffs along the I/O port's edge. Next, take the longer standoffs and fix them onto the DAC's PCB on the RPI interface edge. Put the DAC in place and secure it with the screws. Now take both halves, align the GPIO pins, and firmly push both together to make the connection. Secure the assembly with the 2 long screws and move on to the software side of the project. Volumio has been my player of choice for quite a while now. Its web-based interface works on a desktop computer just as well as it works on a mobile device. For this one, I'm using the new version of Volumio, which hasn't been officially released yet, as it's
以树莓派作为核心，架设于自走车上，用来控制感测器与马达等设备，同时加入轨迹或者是避障功能，使其具有简单的智慧在空间中自行运动。 树莓拍也被用来在探索世界的专业用途。Beach 拍计划就是其中之一。它的目的是在创建一个可以导航横跨大西洋的无人驾驶和环境测量的船只，再利用树莓拍的天线，透过网络将资料传回数据中心。使用探测气球将树莓拍送入近40公里的高空，控制 USB 摄影机拍照，并利用全球定位系统 GPS 来记录轨迹。那透过无线电发送装置将感测资料、位置资讯发送回地面接收站的中心伺服器。
Hello, this is Alex Eames from Raspberry.tv.
Barrel pitch it down, it's not going to be good, is it?
Yeah, you know about that.
What did you say that weighs, Dave? 70 kilos?
70 kilos.
Yeah, I brought one this time.
I didn't. So 6 Energizer lithium AAs down here, they're the lightest and they're the only ones that are spec'd for the cold temperatures. Up here there's GPS receiver, U-Blox GPS, so we know where we are. Pressure and temperature transducer there, and that's a radio transmitter down here. That's just an HD for the battery voltage. Now there's also a temperature transducer down here for external. So actually we've got 3 temperatures, which is that one internal, that one external, and also the CPU, measuring the CPU temperature on the Pi. 2 power supplies, 5 volts and 3.3 volts, and they're just wired directly onto the card. Heatsink on the USB Ethernet chip. And up here, that's a connection to the webcam, which is in the ball at the end there. And there's a 3G for backup. And that's it.
Excellent. And that's all going in this TARDIS.
英国南安普顿大学的 Simon 教授与其研究团队使用64个树莓拍与 LEGO 积木组装成多核心的超级电脑，并透过网络连线进行电脑运算，挑战低价电脑处理高速运算的可能性。透过上述的实例，结合树莓拍与感测器等设备，不仅可以独立作业，也可以透过网络连线与云端伺服器互相交换资料，提供使用者及时的资讯与服务。除了当事件发生时能有对应的动作外，它还能监控各种统计数据，达成物联网的应用。在看过这些实例之后，各位同学对于利用树莓派的应用应该有些概念了。相信大家也都想要赶快使用树莓派来搭建自己的物联网应用。所以在接下来的课程，我们就要正式进入树莓派环境的建制。